welcome back to my channel. Today we shall discuss about the time complexion of the algorithms. First of all, we shall discuss the definition of time complexion, and then we shall classify different types of algorithms based on the time complexion and see each of them with simple examples. And also remember that I'll show you the Python examples here, and for the same algorithm you can use it in any language as algorithms are always language independent. Okay, so let us firstly coming to the definition of time complexion. Time complexion of an algorithm is just the representation of the total time required by the program to run till its completion. That is the running time taken by the program to be completed. Okay, generally the time complexion are represented in big O notation. So now let us see the types of algorithms classified based on time complexion. Firstly, we have constant time algorithms, for which the time complexion is always in the form of big O of any constant. Okay, and then we have logarithmic time algorithms and linear time algorithms, polynomial time algorithms, n-log n time algorithms, exponential algorithms, and finally we have factorial time algorithms. So let us discuss about each one clearly with examples. First on the list we have constant time algorithms. Algorithms that take constant time for running irrespective of its input size are termed as constant time algorithms. That is, what the input size is not considered. Okay, so without any delay, let us see a simple example of constant time algorithm. We have already discussed that the time complexion of constant time algorithms must be independent of input size. So I'll have my input I is equals to some 100, and then I'll have a print statement which takes the constant time irrespective of its input, right? So the value is I, and if you run this print statement twice, the time complexion is big O of 2, but here we are running only the print statement only once, right? So the time complexion is big O of 1. Yeah, so that's for constant time algorithms are the fastest algorithms of all. Next in the list are logarithmic time algorithms. The good example of logarithmic time algorithms is the binary search. Now, in the logarithmic time algorithms, the running time grows in proportion to the logarithm of the given input. So without any delay, let us see a simple example. Remember that an algorithm is said to have logarithmic time complexity if the input size reduces in each step. Okay, so now let us have a for loop here. For I in range, I have the starting value to be 0, and let us have ending value to be 8, and I'll have my step value. Now I'll print my I. Here the I value reduces in each step, right? So in each step, that too by 2, so it is said to be having logarithmic time complexion. Okay, now in our list, next we have, after logarithmic algorithms, the next biggest algorithms are linear time algorithms. Here the running time is directly proportional to the input size. Let us see a simple example. Now here I'll have my I range to be n. Let me take my n value to be 8. Okay, I'll run my program now. Yeah, it has run 8 times. So here the time complexion is big O of n, that is big O of 8. Okay, Here the time complexion differs by changing my input value, that is my n value. If I change this 7, it runs 7 times. If I change this to 6, it runs 6 times, and if I change it to 100, it runs 100 times. So it depends on the on the input size. Okay, so next we shall see the polynomial time complexions. Here I'll have my first for loop to be same, and I'll have another for loop here for j in range. I'll again have 7 here. Now I'll print I and j. I'll run my program now. See, it will be running 7 into 7, which is 49 times. Okay, the program has run 49 times here. Our I and j has been printed 49 times, which is 7 into 7, that is 7 square, 7 power 2. So here, if you have another for loop, it runs 7 power 3 times. If you have another for loop, it runs 7 power 4 times, and it depends upon the number of for loops here, and as well as the input size. Okay, now next we shall see n log n type algorithms. I'll have my first for loop same here, and for second for loop I'll have a step value of 2. Okay, here the j value reduces each time by 2, and the I value each time increases by 1. Yeah. So this is an example of n log n type algorithms. The factorial algorithms, the runtime is proportional to the factorial of the input size. So that's all for today. We have these kind of algorithms based on the time complexion, and in the next video I'll show you how to calculate time complexity for different programs. Okay, so that's all for today. Bye.